Let us talk about 3D printing. What is 3D printing? We'll see what are its general principles, what is 3D printing methods, the applications, the challenges and the conclusions. So what is 3D printing? For methods of applying a 2D image on a 3D surface. Okay, you have a 2D image. Now let us apply this on a 3D surface. So it needs additive manufacturing, or 3D printing is actually a process of making a three-dimensional solid object of virtually any shape from a digital model. If you have a 2D or any model, 3D model, you can make it solid like. So 3D printing is achieved using an additive process. This is an additive process where successive layers of materials are laid down in different shapes. Okay, this additive manufacturing is what? Additive manufacturing, it actually refers to technologies that create objects through sequential layering process, one layer, second layer, third layer, okay, in a specific shape. So objects that are manufactured additively, that can be used anywhere throughout the product life cycle. So what are the general principles of this 3D printing? First of all, modeling is there. First you need to model it, then print it, and finally once the print output is received, you need to give it a finishing. So the modeling first aspect is modeling. Additive manufacturing, which takes virtual blueprints from SCAD, that is computer aided design, or animation modeling software. So you need a software for that, and this slices them into digital cross sections for the machine to successively use as a guideline for printing. There is a model. Now it needs to be divided or categorized in such a way so that it can be layer wise printed. Then to perform a print, the machine reads the design and lay down successive layers of liquid, powder, sheet material to build the model from a series of cross sections. So now here comes the material which is actually used, which is some liquid, powder, or whatever material which is required. So these layers, which corresponds to the virtual cross section from the CAD model, they are joined together or automatically fused to create a final shape. They may because there are different parts as categorized by your software, and these parts needs to be combined. So the primary advantage of this technique is its ability to create almost any shape or geometric feature, right? Any feature it can be governed and produced by this 3D printing. And finally, once you receive the product, there is a finishing aspect, because though the printer produced resolution is sufficient for many applications, printing a slightly oversized version of the desired object in standard resolution and then removing materials from higher resolution, subtractive process can be achieved higher resolution. Okay, there is also an idea or a technique by which this slightly oversizing version can be in a specific standard resolution can be removed, material can be removed. That may be a subtractive process. So different methods are there. First of all, we have selective laser sintering, SLS it is called. We have stereo lithography, then we have fused deposition modeling and laminated object manufacturing. There are various methods which are available. Let us talk about selective laser sintering, SLS as it is called. So we have selective SLS, which is a additive manufacturing technique that uses a high power laser. For example, we have a carbon dioxide laser to fuse small particles of plastic or a metal, which is called the direct metal laser sintering, and ceramic or say glass powders into what? Into a mass that has a desired three-dimensional shape. So we have a laser, this is the scanner, this is the powder I was talking about, this is the roller, and each layer piston goes up and each layer piston moves down. So through this selective laser print sinistering takes place. Then we have stereolithography. What is this stereolithography? This is again a additive manufacturing process using a vat of liquid ultraviolet curable photopolymer resin, right, and a UV laser to build parts a layer at a time. So here we have a vat of liquid UV ultraviolet curable photopolymer. So we have a laser again. This is a scanner system, because there has to be a scanner. We are talking about printing. This is the laser beam, and this is layer of solidified resin which I just talked about, and this is the liquid resin, and this is the platform and piston. So every time there is a laser beam and this piston goes up, goes down, and final product is what we receive. Now this stereolithography also has this CAD, computer assisted design. This CAD program, it actually helps user to create this STL files for the 3D printers to read. This STL stands for stereolithography, this STNL, this file format, which uses many little triangles. These are the various different triangles to make three-dimensional plot of the object intended surface. So if we have idea about or how to print these triangles separately can be made and can be combined in this way. Now we have a FDM, that is fused deposition modeling. This FDM is again an additive manufacturing technology which is commonly used for modeling first, then prototyping, and then production of application. This fused deposition modeling. Now here we have you see, this is the setup. We have this part, these are the past objects, these are the part which we are going to make, and this is a build material spool. This is going up, and support metal spool. Then we have build platform. Here we get the final product. Then we have a foam base. We have support material filament, build material filament, extrusion head, dry wheels, liquefiers, extrusion nozzles. So this is the whole setup for our FDM. Then laminated object manufacturing also there. This laminated object manufacturing, or in short we call it as LOM, is again a rapid prototyping system which was developed by Helices in INC Incorporation. So in it, layers of adhesive coated pair, please listen carefully, in these layers of adhesive coated pair, plastics or material laminates are successively glued together, one by one glued together, and cut to shape with a knife or a laser cutter, right? So here is a laser, this is the mirror, this is the moving optics head, this is the tile, this is a layer contour. Now these are the blocks, this is the platform, this is the sheet, so the sheet goes there, and this particular shape can be cut and in a different and in various layers, and they can be combined together. This cutting is done by laser, and this sheet material is the provider, and sheet materials can be glued together. Now the applications of this 3D printing is prototyping, it is modeling, we can make custom parts, you can design also, and still it is in research stage. Now what are the challenges in 3D printing, because this is no doubt a very sophisticated and state-of-art technology, but intellectual property rights of 3D printed users, this is one of the aspects. What about the IPR? This needs to be settled down, and now nearly anything can be printed by a 3D printer. Now this is a trouble for criminals. If criminals are able to make these things with 3D printers, these are the illegal products, Now what are we going to do then? So these are the challenges which needs to be addressed. So nothing communicates ideas faster than a 3D part or model. If you have a figure, if you have something in 3D, it communicates the idea faster, and with a 3D printer you can bring CAD files and design ideas to life. So right from your desktop, you have a nice desktop, you make a model, you give a print command, and that final 3D product is printed. Okay, so test, form, fit and function, and as many design variations as you like with functional part. This is the important part of our 3D printing. So hope you got a basic idea of 3D printing. You need more study for this. Thank you so much. Take care.